Hello, everyone. Thank you so much for attending our Optics Lives series webinar. Today, we will focus on Optical Cross Connect, OXC. This is Hivi, the moderator today. I'm the communication specialist of Huawei Transmission and Access Network product line. Before we start, I'd like to remind you that you will receive the follow-up email after the webinar. And if you need more resources, please feel free to let us know. If you have any questions during the webinar, please leave them in the question box. We will reply them at the end of the webinar or send answers to your registration email. First of all, let's welcome today's speakers. They are Mr. Zhao Minghan, Senior Architect of China Telecom Sichuan Transmission Department. Mr. Jose Manuel Silva, Chief Technology Manager, WDM of Telefonica Spain. Mr. Zhong Feng, Chief Architect of Huawei Optical Cross Connect. Okay, let's start now. Hello, John, are you there?
Yeah, I'm here.
Could you please start now?
Okay, so it's very glad for me to introduce the Huawei OXC technology and the corresponding product to the audience. So here follows the presentation today. So first about the market trends and challenges, and then some key technologies and values of the OXC, and then key sharing from our customer. Then our view on the following ages about the OXC and the conclusion. So, I think as we all know that from 1980s to now, almost every 10 years, the whole society will upgrade to a higher level. So that means from the voice ages to the video ages, and for the nowadays like AR, VR ages. So this kind of various applications to drive the whole network to bandwidth and like latency, and to to upgrade in the 10 times magnitude for 10 times. So about the WDM network, so we all know that because of the huge bandwidth requirement, so it's driving the formal like a mesh network, mesh backbone network into the, we call it a 3D meshed backbone network. That means because of the imbalanced or heterogeneous traffic, so some link will be as you can see here, we call it the hot link. So we need to reconstruct the whole network into a 3D. So that means to release the pressure about the bandwidth on some specific links. Meantime, with the video and the 5G service comes to our life. So we were driving, the whole network was driving the OTN to the central office. And that means the whole network will be flattened from like former like 5 layers to 3 or 2 layers. So that means the lambda will and can be from the central office directly to the core network. So that driving the node degree of the core network to be increased dramatically. So we show that more than 2 times, 4 times, and even 8 times increase. And third, that the data center collection requires the high reliability and low latency collection, and also driving the whole network to become the full mesh network. So this also driving the node degree to increase dramatically. So all these matters and driven the whole network and the nodes, the degree of the core nodes to increase dramatically. So if we look back to the history, we will see that the site capacity is growing exponentially. So we will see that in the coming 2 or 3 years, the capacity of the site will more than like 400 terabit or even to 1 petabit. So this is really give some impress to the network. And if we look at the node degree, and from the view of statistics, we will see that the mean degree of the whole network is generally 6 to 8. But some core node on the backbone or on the core network will up to like 20 or even 30 degrees, especially for the full mesh network. So that means we need some kind of a new way to think about how we to make optical networking. So we also learn something from the history. So maybe 20 years ago, so the WDM network used the AWG-based technology, but which is only can connect 1 or 2 degree, but by manually. And then the wavelength selective switch technology was coming, but this is somehow to change the whole network to the we call it semi-automatic. Because of in the line side it is automatic, but in the airdrop side it is not so flexible. What I mean that you will see that because we use AWG, so all the ports is colored and also direction. So for the airdrop side, it's not so flexible, and it is inconvenient for the customer to use. Then we move to the colorless and directionless. Use this kinds of whole WSS-based technology, but there are some wavelength blocking here because of there is one fiber collection between these two back-to-back WSS. So the wavelengths will be conflict. So then introduce the contentionless technology. But this kind of CDC ROADM use the fiber pigtails, massive numbers, hundreds of, or even thousands of fiber pigtails to collect all these kinds of cards and ports by manually. So you can imagine that this is really a challenge for the customer. So we introduced the optical backplane based optical cross connect technology, then to solve these kinds of challenges and make the whole network to be autonomous from automatic. So there are some key technologies about the OXC. So in the before the OXC, people developed various kinds of technology like a wavelength blocker, so which is only to block the wavelengths which is not used, and it can only apply in the 2 degree node, and then move to the PLC. But this kind of PLC is only to deal with also 2 degree node. So in the 20 years ago, this kind of modules can be very good, but if we move it to nowadays network, it cannot satisfy the high degree. But the WSS also has some problem on the mention that blocking things, and also the reliability issues. So we introduced OXC. So in principle, the OXC is made up by 3 parts. So one is the we call it line part or line board. So this kind of line board is function is to like a 1x(n) switches, but wavelength switches. So it can split and to choose the design, the wanted wavelengths to be switched to the wanted ports, and optical the tributary board. So this kind of board is make the M/N function. So that means it can select N channels from M ports or M degrees to the airdrop module. And all this kind to function boards is connected by the optical backplane. So like electronic backplane. So the kinds of a backplane is totally highly integrated, and it's very reliable and not easy to make a broken or something like that. And from the module side, so we can see that there are three key technology about this OXC. So as mentioned, that's about the optical backplane. So in this optical backplane, you will not see any fiber pigtails. So it's totally like PCB, but we call it fiber circuit printing technology. So a whole thousands of fibers just printed in one kind of paper sheet. So it very high integration and high reliability and to easy maintenance. So about the ADWSS side, we introduced the LCoS liquid crystal silicon-based ADWSS. So this kind of module is to change the whole network dramatically. So that means that there's no contention happened in this kind of OXC system. And also there's no optical amplifier. So that means it is high reliable and also easy to make expanding for the ADWSS ports. In the meantime, because we use the OXC, that means almost all the information is in the optical domain. So we need some way to monitor and to know exactly the performance or the states about each wavelength. So we introduced the digital optical OM function. So we use some specific technology like light sensor technology to know exactly the wavelength information like this power and this distillation and its collection link various information about this. So about the optical backplane, so you will see here. So I think optical backplane, this concept is not new, but this is the first time we introduce this kind of concept into a commercial product. So maybe 10 or 20 years ago, in academic society, people talking about the optical backplane more on the how to print the waveguides or the fiber on the paper side board, but it's not just to print the fiber, but how to make this kind of very high dense interconnection. As you see here, there is a very high dense optical connectors up to 72 ports, and with very good dust proof function here. So it is immune to like a PM 2.5 level. And also we use non-contact connectors then to make this plug function to be almost endless. So there are a lot of innovations on the material side. As here, I can give an example. So I think most of people know that if the thermal expansion is not coefficient with about the fiber pigtail and the collector, so there are something will be broken here. So how to find the material that can satisfy the same thermal expansion coefficient is very important. So our team to develop this kind of specific material to use in the optical connector and also the fiber tails. In the meantime, how to make automatic fiber printing technology is also very important. So this is the key for the efficient manufacturing. So we collaborate with our industry partner deeply to invent this kind of big equipment to make this kind of backplane into a real commercial industry society, right? So about the LCoS-based ADWSS technology, this is something very traditional space optics and the digital optics. So why I call it digital optics? Because we use the liquid crystal technology. So this is a very interesting components. So in traditional, for example, for the maps, we use a mirror to reflect and to make beam steering. But for the LCoS, we use something like a diffraction, not refraction. We use diffraction to make the beam steering. And this is not some mechanical movement, but we use the electronic to driving the phase changes in the liquid crystal. So there's no mechanical parts. So that means it is very reliable. And meantime, we use the very how to say very innovative algorithms to make this kind. We call it hologram beam steering. So you can see here there are some diagram to show the phase pattern about the on the LCoS. So we use different phase pattern to make different beam steering. That means we can to steering the whole optic spot on almost on the whole surface. That means we can increase the switching ports like even 2 times and even 4 times increase. So this is basic for the OXC system. So people may asking why we choose the liquid crystal silicon. There are like DLP and like a liquid crystal and like MEMS. Why I choose the liquid crystal silicon? So in this table you will see that I think the main contribution about the liquid crystal it means because it introduced almost griddless properties about the optical switches. So this griddless, or we call it a flex grid function, make the optical layer can be almost upgrade seamless with the transmission technology, like from the 100G to 200G to 400G, even for further 1 terabit. So you don't have to change or your invest on the optical layer. So this is the main contribution, I think, to the liquid crystal, and compared to the MEMS. So because there's no moving parts, so its reliability is very high compared to the MEMS. And I just mentioned before, so if all the information is on optical domain, how we can know the like healthy or the state about each wavelength? So we introduce the light sensor technology. We adding some palotone to the optical signal, and in the very simple and zero cost way, then and detect almost everywhere in the network. So we can know exactly the wavelengths where it is come from, and what's its destination, and what is wavelength number and power, and almost OSR about this lambda. So this is very important for the adaptive network, and also this is I think the necessary function about the OXC and networking. So I think because the OXC system is highly integrated, so in the former 1 rack for 1 direction, but in the OXC system, so almost 1 card for one dimension. And although we meantime, with the high integration, we also keep the high reliability. So you will see the main parts about the OXC system. One is the wavelength selective switches, and secondly, about the add drop part, and third is the optical backplane. So in every way, we make some innovations on each part and to make it with the same reliability. So from optical backplane, so the left side is a traditional way. So you will see that people use various fiber collection to collect different card, different ports, and because this is by manually, so it is easy to make some mistakes. For example, the fiber cards or the loose fiber make high insertion loss, something like that. But if we introduce the optical backplane, all these things are gone. So that means this is automatically, almost all the things is automatically, and we use the high precision equipment to make this, all the things are precisely under control and make the whole system is very reliable and lower failure rate. And for the component parts, so also the left side is traditional multicast switch technology. So you will see here there are a lot of optical amplifier here. So we will know that the optical amplifier is a main failure part about the network. So there the MC in the MCS solution, they integrate almost like up to 16 or even more than that amplified here. So the failure rate is very high. But in the ADWSS OXC technology, you will see here there's no pump nadir here, there's no EDFA here. All the parts are passive. So that means it is more reliable. And also its insertion loss is lower than the MCS solution. So all these things make it better compared to the MCS. And not just to make a very highly reliable components, Huawei also introduced the industry unique tested equipment and environment. So you will see here there are some thing unique in the industry. For example, for the dust accumulation test chamber. So this is, I think, there's no other solutions in the industry. So in this test chamber, we test all the kinds of dust accumulation scenarios to make our OXC system can be working various conditions. And also, we developing the no pressure test chamber. So we know that in the higher applications, like in some high mountains, the pressure is lower. So there are some the risk for the pressure for the leakage. So in this test chamber, we will know to guarantee and to make the whole system is totally hermetic. So for conclusion, so we used kind of full level protection for the whole reliability and stability from the component to the system and to the network. So here are some information about the OXC. You can take away. So there are four advantages of the OXC. Firstly, huge capacity. So use the OXC, we can up to 32 dimension and one card for one dimension. And the whole capacity for the rack is can up to 600 terabit. And the whole architecture can be scaled out to 1 petabit. And there is no fiber collection manually. All the things is done in the backplane, so there's no zero fiber collection, and means there's no errors introduced by manually. And also we introduced the industry first ADWSS. This is make it very no insertion loss, zero blocking function. and also use some digital OM technology to make the number can be digitalized and make number as a service to know exactly it's healthy and its information. All right. Yeah, there's some introduction about the OXC. Yes.
Hello, everybody. Could you please check the right of your screen? There is a poll button. You click the poll, then you will see the poll questions and the answers. Could you please select?
Hi, Jonathan. Can you experience your opening about the poll result?
Okay, so here I say the poll states. So I think most of the people think that the OXC can be used in the backplane and the metro core. I think this is something the same thing. We think what OXC can be applied. So in the backplane in the metro core, so there are a lot of data center and more degree, more capacity needed in these two kinds of network. So I think, especially for the metro core, its degree requirement, I think, is more in the backplane. So in the backplane, more like how to say the direct connection. But in the metro core, I think the network is more fully masked. Okay, so here are some case sharing from our customer.
Okay, let's welcome Mr. Zhao Minghan from China Telecom. He will share with us OXC builds an optical cube to facilitate 3D backbone network. Hello, Mr. Zhao Minghan, are you there? Could you please start now?
Okay. Hello, everyone. My name is Zhao Minghan. I'm the Senior Transmission Network Architect of China Telecom Sichuan. Today, I will show you the OXC commercial practice by China Telecom Sichuan. Why we need OXC, how we do, and what benefits can OXC bring us. First, I will introduce you the company China Telecom and China Telecom Sichuan. China Telecom Group was established in September 2000. It's a very large communications company in China. It has been selected as a world's top 500 enterprises for many years. Mainly engaged in flexed telephone, mobile communications, satellite communications, and internet access and application. As December 2019, it has 300 million mobile phone users, 100 million flexed phone and broadband users, and more than 400,000 employees. Just as you know, Sichuan province is a place rich in products. It's panda home and have so much delicious food, such as hot pot. China Telecom Sichuan is a branch company set up by China Telecom Group Corporation in Sichuan and undertakes general telecom service, public communications, and information service in the province. According to the plan of Sichuan province, from 2018 to 2020, more than 10,000 new enterprises will be used cloud service. As the largest IDC and cloud service provider in the province, China Telecom Sichuan owns the largest national level information industry multi-dimensional convergence platform in the West, China West Information Center, and is the first national data security center in the country. Okay, hello, next page. As everyone knows, um, many customers brings a lot of traffic and the network bandwidth requirements. As does Sichuan Telecom, in recent years, we have found that the current network is becoming increasingly difficult to meet the demands of business development. At the same time, the emergence of new services such as 4K and 5G brings great challenges to the network. First, due to the different usage habits of target users and the uneven distribution in the region, the traffic in different links of network is seriously uneven. In Sichuan Telecom, the average channel optimization rate is less than 30%, but the data of the core 11 links are more than 75%. Second, the network expansion cycle is long. The traditional network expansion method requires coordination of many resources, such as space, power supply, air conditioning, and the preparation of many materials, such as equipment, boards, fibers, and cables. It also involves a large number of fiber connection and sites. If traditional ROADM solution expansion method is adopted, the construction period is up to 2 months. In addition, the site resources are also a problem. There are bottlenecks in space, power supply, and air conditioning of multiple core nodes with traditional solutions. One thing to emphasize is high reliability requirements. Just as you know, Sichuan is a seismic zone between the Asia, Europe, and the Indian Ocean plates. In the past 19 years, 6 earthquakes of magnitude 7 have occurred. So we need product must can resist frequent earthquakes. Okay, next page, John. Page 28.
Yeah, this is page 28.
Why we choose OXC solution? The solution brings 3 benefits to us. First one, we use a 3-dimensional backbone network architecture and only need to expand 40% of high traffic sites to solve the network capacity problem and save investment. The second, based on OXC's highly integrated platform, only one board needs to be expanded in one direction. At the same time, flexible scheduling of a service can be quickly completed through network management system, as well as visualization of network resources and performance, which can quickly achieve fault demarcation and service delivery, which greatly accelerates the progress of the project. And the entire project was shortened to 2 weeks. In addition, the OXC solution using optical backplane technology greatly saves the room space, power terminals and power consumption. We have calculated the compared with the traditional ROADM solution. The OXC solution can save 25 kilowatt per hour in a year, equivalent to planting 2,000 trees. Contribute to energy saving and environmental protection in Sichuan. Of course, the OXC solution reduces the fiber connection between subricks and greatly reduce the difficulty of maintenance. Last one, the equipment has passed the earthquake intensity 9 anti-seismic performance test. Can defend against 9 magnitude earthquake. Based on the above, we found that OXC solution can well meet the business development of Sichuan Telecom. Okay, that's all I want to share with you about OXC commercial practice by Sichuan Telecom. Thank you very much.
Thank you very much. Now, welcome to Jose.
Yes, thank you. Hello, everybody. I'm Jose Manuel Silva. I'm in charge of the Transport Network Technology team in Telefonica, Spain. I've been working in this area for the last 8 years, and it's a pleasure for me to be part of this webinar. I would like to start giving my condolences to everyone that has a relative or friend affected by the virus. I hope that soon we will be able to go back to the office and see each other face to face. That would be good news for everyone. Please, next page. Telefonica and Huawei have been working together in transport networks for more than 12 years. We deployed the National Transport Network, becoming one of the first ASON networks in the world. And since then, Huawei has been part of all the Telefonica transport network layers, including core, metro, and access. 12 years is a very long time when we talk about technology evolution. And we have seen networks changing from point to mesh topologies, from 1 port per board to more than 20, and from 100G slot capacity to 1 tera. At the beginning of the National Transport Network, we deployed 40G non-coherent channels, and today we are thinking in the next network with 400G channels, and we are even thinking in 800G and 1 tera channels for field trials. Everything is changing so fast, but we are not all interested in traffic growth, with each certain and predictable for us. We need to look farther. In fact, one of our main goals today is to achieve a very high level of network automation in order to simplify and reduce the operation and maintenance tasks. And automation needs data. Every project we have in our minds related to automation starts with network data. We need access to every single data generated by the transport equipment and management systems. And this data should be in real time, reliable, and accessible through standard interfaces and formats. We hope all our vendors understand how important data is for our future. At this moment, more than 40% of our team is working on automation projects, and the whole company is going on that direction too. So I'm sure that Telefonica and Huawei working together will lead the path on network automation. Please, next page. We have always tried to be ready for the future, and that's why last year Telefonica and Huawei started a new project called Innovation Lab. This new lab is designed to test all new features and equipment coming, even during the development stage when they are not available in the market yet. This lab allows us to see and test how our future networks will be, and gives Huawei the opportunity to receive feedback from one of their main customers when they still have time to fix problems or improve some details. The Innovation Lab is also the first step towards the field trials as a previous stage to the field scenario. In the Innovation Lab, we have already tested 200G channels, 400G channels, cluster configurations and Raman amplification, for example. And of course, related to the topic of this webinar, the last equipment we were lucky to test was the optical cross-connect. The first time we heard about the Huawei optical cross-connect, I must confess that I was a little bit skeptical. This whole idea of the optical back panel reducing front fiber connections sounded like science fiction to me. But soon after, we had the opportunity to see the back panel in the Huawei headquarters in Madrid. I started to believe that it was something real. At the beginning of these years, like I said before, we could test the optical cross-connect in our innovation lab. We have made a very, very detailed and deep test, just like all the tests we do on the equipment we deploy in our networks. We set up a scenario with both P32 and P32C with all the boards available at the moment, working together with the existing UPS platform. Once we faced the lab configuration, we realized that the fiber connection reduction was obvious. Every internal connection is done through the back panel, and that's a huge benefit in order to avoid operation accident and configuration mistakes. Using optical cross-connect, connecting one network element to another, deploying a new direction in a ROADM became very simple. We just have to plug one line board, and all the internal connection between WSS and amplifiers are automatically created in the management system. It's a faster and a safer process. Of course, thanks to the high integration level, we are reducing space, which is also a goal for Telefonica, together with power consumption reduction. And due to this integration, P32C is enough for most of our network elements, and we will need only to use P32 in some special cases in the metro network for network elements connected to many neighbors. Optical cross-connect is also simplifying spare parts. Using this equipment, we will only need 4 or 5 different boards, which are very easy to replace, reducing bad configurations, like I said before. We have also seen features that Huawei need to improve in the future. For example, the performance of FlexGrid. FlexGrid is a must for the future, and all the functionality should be perfectly implemented, like they are in other Huawei products now. We have seen that FlexGrid is not 100% well handled by control plane in optical cross-connect, but we are sure that these little bugs will be fixed soon based on the feedback given by our testing. In conclusion, the optical cross-connect test in our innovation lab was very successful. We have seen a product ready to the market, and it was a very good surprise for all of the transport departments in Telefonica, from planning to maintenance people. We are really glad of how Huawei is working in innovation, and optical cross-connect is a perfect example of that. Innovation is not only important for transponder, pluggables, or modulations. ROADM structure, space, power consumption, and automation are also very important, and we hope other vendors work in that direction too. Of course, there are things that need to be improved. We also have to think about how it fits in our network, but I look forward to seeing optical cross-connect in our transport network. We will continue working together for many years in the innovation lab, in field trials, of course, in the deployment of our transport network. I want to finish my speech thanking Huawei for giving me the opportunity to be part of this webinar and share our ideas with so many colleagues.
Okay, thank you, Jose. Thank you very much.
You're welcome.
Now we are going to poll questions. Okay, everyone can spend 5 minutes to make a choice. The poll questions is on the right side of our screen. The question is, what are the most expanded benefits of use optical cross connect? Could you talk about the poll results?
Yeah, let me see here. Right. So I think people who select the OXC, I think main for the network automation, and also about the switching capability, and also can lower the total cost, right? So in generally, I think OXC can provide the highly integration. So I think we can provide very cost-efficient solutions for our customer who is need higher integration. And for the OXC, I think because with the coming about the 200G, 400G, and 800, and even 1 terabit, the switching capacity will become an issue in the electronic domain. So I think in very near future, I think optical switching will be more and more important for the site for the switching capability. And because we will add more and more fiber in the network and more wavelengths in the network, so I think it also will become an important issue in the future WDM network.
Thank you. Could you please start now?
Right. So here we also give some visions on the OXC. So in the future, we're not just not only just to increase the capacity about the higher node, but we also want to introduce the mini OXC in the like central office in a lower node. So in the future, maybe we can introduce some very simple optics, free space optics in this kind of site, and also introduce the silicon photonics into this kind of site to provide more cost-efficient solutions in this lower degree site. And for the high degree sites, we will introduce like more than 32-degree technologies. And in architecture, we can introduce some kind of scale-out architecture that we can almost provide up to 100 degree OXC for the future high-capacity optical network. All right, so here's the conclusion. So with the development of like a data center and video and AR, VR, I think there are some higher requirements on the network, like node dimension and capacity, latency, and like site degree, and also driving the whole network to be flattened, meshed, and to become a 3D dimension reconstruction. And the new generation OXC, based on the wavelength level switching, so it can provide large cross-connect capacity up to like more than 500 terabit, and also provide the highest integration in the industry and the highest reliability in the industry. So I think this three innovative technologies like optical backplane and LCoS-based switching functions or modules, and also the digital optical OM functions can provide our customer network to be upgrading with requirement for the various services. So in future, we will also look deeply into the lower metro access scenarios, and also look up on the optical backbone scenarios with higher dimensions to make our customer network to be more strong. Yes. Okay.